Is this a math problem? Yes or no? How do you know that? Well, look at, what are these things? Addition, subtraction, there's equal signs. Yes, it's math. Math doesn't have to be X and Y's and stuff. It can be pictures. So the first thing you have to do is convert this to a math statement. The first line, we have 1, 2, 3 hamburgers equals 30. We have 1 hamburger plus 1, 2, 3, 4, 4 rolls equals 18. We have 2 rolls minus 2 Cokes equal 2. 1 Coke plus 1 hamburger equals what? It's a math equation. Let's work our way down. So 3 times H equals 30. What does H equal? 10. Because we're trying to get H by itself. How are they connected? What operation is connecting them? Multiplication. So what's opposite of multiplication? Division. So I divide 3 to both sides. So each hamburger, each H, is worth 10. So we have this one. We have 1H plus 4R equals 18. And H is 10. So it's 1 times 10 . 1 times 10 is 10. So 10 plus 4 was 18. How do we solve this one? What do we do first? When you solve equations, it's the opposite of the order of operations. Get rid of the least important stuff first. What's the least important? Yeah, the 10. How do we get rid of it? Subtract, because this is a positive, so we subtract 10 from both sides. (18 minus 10 is 8. Get the R by itself. It's 4 times R, so we divide both sides by 4. So each R is worth 2. Now we have this equation. We have 2R minus 2C equals 2. We know that R equals 2. Two times 2 is 4. Get rid of the what? Get rid of the 4, because we're trying to get C by itself. So it's a process of opposites. Subtract 4 from both sides. Negative 2C. 2 minus 4 is what? Negative 2, because 4 is bigger than 2. It's negative. 4 minus 2 is 2. What's your next step? Okay, here's what I try to show you guys things that will decrease the chances of mistakes. Never divide by negatives. If you divide by negatives, you'll have signs all over the place. Treat the signs and the numbers differently. Since that's a negative, we're trying to get to C, just change every sign across the equation. Any plus, change it to a minus, any minus, change it to a plus. So it becomes 2c equals positive 2. Never divide by negatives. Now we divide by 2. So c is equal to 1. And the last equation is 1c plus 1h equals the unknown. We know that c is 1. We know that h is 10. 1 times 1 is 1. 1 times 10 is 10. So the answer is 11. This shows you how to break things down to mathematics, but it also shows observation skills. The most common mistake everybody gave me was 12, because they saw 2 Cokes here. There's only 1 Coke here. So 2 Cokes equals 2, 1 Coke equals 1. So there's an example of how we use mathematics. If you're given a problem, try to convert it to an equation or a series of equations. Again, that's how I'm going to do the exit tickets from now on. I'll give you some kind of puzzle type math over the stuff we've covered. And then anybody who finishes can leave early. Anybody who doesn't can sit here till I get tired. So let's begin. Chapter 1, Section 1. What are integers? What are whole numbers? What are natural numbers? You've heard those words before. You once learned them in elementary school, but you've forgot them since then. What's a natural number? Let me help you. If I ask you to count to 5, how would you do it? What would you do first? Starts with 1, and it goes on to infinity. Natural numbers are also called our counting numbers. What's a whole number? How do they relate to natural numbers? The only difference is these begin with a whole. Infinity. Whole numbers begin with 0 and go on to infinity. Natural numbers begin at 1, go to infinity. What are integers? What else is missing in this? You notice what we're doing here. We have 1 to infinity, 0 to infinity. What's the next step? Negatives. Yeah, so this one goes from negative infinity to 0 all the way to positive infinity. The integers You were first introduced to those by the number line. We have 0 in the middle. Anything to the left is negative, all the way to negative infinity. Anything to the right is positive. Then you were introduced, find the number 2 on the number line. How would you indicate the number 2 on a number line? What would you do? You'd put a dot right there. That is called a point. A point is the location of a number. And it's pretty interesting how this goes. We were first introduced to number lines, horizontal line. Think about how humans traveled. In the beginning, how they traveled? Walking, riding on horses, riding in wagons, bicycles, cars, trains. All that moves horizontally. And then what happened? We have airplanes, submarines. We now can go up and down, not only left and right. Remember, here was 0. So going up is positive. And going down was negative. So we have to label these things because we're used to putting points on the horizontal line, on the number line. But now we have other locations. If we put a point there, it had to have a location. So that point, its location is called the coordinate. Locations and coordinates are the same things. The question became, how do we differentiate that number from just this number? The reason it's called a coordinate because the horizontal axis was called the ordinate and the vertical was called the abscissa. So coordinates. So this location is made up of two parts. We call the horizontal axis the x-axis. And we call the vertical axis the y-axis. Because everything, but alphabetically, x comes before y. The horizontal line came first. So every point is coordinated the same way. The x comes first, the y comes second, always. So what is that location? What is that location at that point? 2, 3. What is the location of this point? Here, I call this point A. I'll call this one point B. What's the location of point B? -4, 1. The location of C? -3, -2. And location of D. What's the location? Here's E. What's the location of E? Just 0? 0, 0. Has to have 2 points. It's 0 on the X, 0 on the Y. You don't go anywhere. That's called the origin. Origin means what? The beginning. That's where it begins. Every one of these points begins at 0, 0. If I said go to the point 2, 3, you'd first go 2 on the x-axis, 2 positive, up 3. There's 2, there's 3. This one, from origin, go -4, negative is left, and up 1. Negative is left, -3, and negative is down, -2. So that's how we go to the points. So far, so good. You've all seen this before. Now we have 4 of these things. What are they called? You have 4 corners. What are they called? Quadrants. We have 4 quadrants. When we name the quadrants, we use Roman numerals. 1, 2, 3, 4. If we were to name these 4 quadrants today, where would 1 be? Top left. And then 2 would be top right. And yeah, we'd go clockwise. But guess what? They didn't have clocks back then. What did they use to tell time? The sun. Where does the sun rise? Where does the day begin? Where does the sun rise? The east. This is the east. So it begins here and it goes to the west, goes up and then back around. So it begins in the east. So this is quadrant 1. quadrant 2, quadrant 3, and quadrant 4. So far, so good. And everything begins from this. All the formulas, all the equations we have in math begin with this stuff. What quadrant is that one in? Why is it 2? Because this one's negative. It goes, is negative left or right? Left. So it goes left, and then positive goes up. How about 4, 3? So which quadrant? Yeah. From the origin, it goes right up. 3, negative 5? 4. Because it goes to the right, then it goes down. -1, -1. Yeah. Left, down makes it 3. How about that point? 2, 0. Where is 2, 0 at? If you go from the origin, you go 2 to the right. It's right there. Is that in a quadrant? No. These are what we call interquartile. Interquartile. It's between two quadrants. When it's interquartile, it's on one of the axes. This 2, 0 is on the x-axis on the positive side. So far, so good. Now we begin doing the equations. Finished? Finished? Okay. So let's look at this. What can we do five, -1, -5. This is the x-axis. This is the y-axis. If I just gave you 1 point, can you give me an equation of a line? Or can you draw a line through it? Yes. You can draw an infinite number of lines. It could be any way, as long as it goes through that. That doesn't help us any. How many points do we need to be able to draw one specific line? We need to have nothing more than 2 points. So at 5, 4, once you have 2 points, you can connect them. And now you have the graph of a line. To draw a line, you need 2 points. Once we have 2 points, we draw a line. What else can we do from there? What can we figure out if we have 2 dots and we drew a line? What can we figure out from there? We could find the distance between the 2 dots. What else can we do? We could find the slope of the line through the 2 dots. We could find the point halfway between the 2 dots. That's called the midpoint. We can find the equation of the line connecting the 2 dots. That's a lot of stuff from just 2 dots. So let's begin. Once you have 2 dots, let's find the slope. When we say slope, what does that mean? The what? Very good. Yes, that's exactly what it means. The rate of change. But that's more applications. When we talk about a slope, how would you define that in words? How would you define slope in words? Remember, the slope is going from this point to that point. So it has to go, the way slope works is the rise over run. Rise over run. Is it always rise? No. I like to always include or sink. Rise means it's going up. Do all lines always go up? No. Some of them go down. So it's sink if it goes down. It's rise if the slope is positive. It's a sink if the slope is negative. Let's look at these in formulas. What this is defined as is the vertical change over the horizontal change. This is where we start going to mathematics now. When we say the word change, we mean the difference. When two things change, that there's some difference between them. In mathematics, what symbol does difference represent? What's that? Is it add, subtract, multiply, divide? Difference. Subtract. This means this was is a difference means subtract. Because look what we're doing here. Remember, we have a vertical that's up and down. Vertical is up and down, and horizontal is always to the right. So if we have our graph here, how would we define the vertical change? From here to here. How far does it travel? 3? Yeah, how'd you get 3? So let's look at this. Between 1 and 4, how many spaces are there? Between 2 and 57, how many spaces? How many? 35, very good. Between -6 and 15. I don't know, you tell me. Remember, 15 is over here somewhere, right? -6 is over here. So we have 6 here and then 15 here. 21. So let's look at these. From 1 to 4 equals 3. From 2 to 57 equals 55. There's a formula here. So if we take 4 minus 1, we get 3. If we took 57 minus 2, we got 55. If we took 15 minus -6, which is 15 plus 6, we get 21. So what's the equation here? So if I gave you two numbers, 5 and 218, what would that be? Yeah, one of those. Yes, 213. Because we go 218 minus 5. Right? So we have, this is the first number, this is the second number. We use subscripts to represent numbers. We can't just put x minus x. This x is the first x. This x is the second x. So the difference between two numbers is always going to be the second x minus the first x. Or if these were y's, it would be the second y minus the first y. So when we say rate of change, we're actually talking about the difference of them. So the slope is equal to, what's the vertical change? In the vertical change, we start off with this one. So this is y1, this is y2, this is x1, this is x2. So this point is x1, y1, x2, y2. 1, 1, 5, 4. So what would the vertical change be? Y2 minus y1. The horizontal, x2 minus x1. So there's our formula for the slope. But we don't always want to keep on writing slope, the word slope. So in mathematics, we use the symbol m for slope. There's your first formula. The slope formula. So many things begin with this. Actually, this is where you begin calculus with that equation. You don't need graphs anymore. Find the slope of the line connecting those 2 points. So to find the slope, to find m, here are the steps. Define x1, y1, and x2, y2. And it doesn't matter which ones you pick, in which order, because they're going to be the same slope. So how would you typically pick the first point to the second point? Well, yeah, as you're going to the right, whatever dot you get to first, that's x1, y1. So, for example, here, if I take my pen like this, whatever point I get to first, that's x1, y1. The next point is x2, y2, and so on and so forth. So it's as we read left to right. So in this case, this is the first point I get to. So that's x1, that's y1. This is x2, y2. Step 2, Label x1, x2, y1, y2. So what is x1? What is x2? Y1 and y2. Once you label them, it'll decrease the chance of error. Because the most common mistake students do, if they just try to use the points themselves, invariably, the most common mistake, x1, x2, y1, y2. Because it's easier to read that way. So no, label each point as an x and y component. Place the slope formula. So, we have m equals y2 minus y1 over x2 minus x1. Plug in the values and solve. Plug in the values, then solve. What do we get here? Yeah, so y2 is 29. Y1 is 8. X2 is 10. X1 is 3. (29 minus 8 is 21. 10 minus 3 is 7. Simplify if possible, so this becomes 3 over 1, or 3. You have to remember that if the slope is an integer, 3 or 9 or whatever, you have to remember that it's a fraction. When we talk about slopes, you have to have a fraction when we deal with slopes. Decimals are worthless. Why do we want fractions when we deal with slopes? Because let's look at this. Let's look at the slope of this first one. The slope of this equation would be what? We have 1, 1 and 5, 4. What's the slope of that equation? What's y2 minus y1? X2 minus x1. What is y2? 4. What's y1? 1. X2 is 5. X1 is 1. So our slope here is 3 over 4. This tells me a lot more than 0.75. Slope is a direction. What it says, from my first point, what do I do? Since that's positive, I go up 3 spaces. 1, 2, 3. Then I go to the right 4 spaces. 1, 2, 3, 4. The slope is a guide from one point to the next point. So the next point is going to be up 3 over 4. So you can tell me infinitely many number how many points are on that line. Infinite number. That's what it's used for. So whenever you deal with slopes, the answer has to be either if it's an integer or make it a fraction. So far, so good. Let's do one more. Find me the slope. Find M. Find the slope between those 2 points. Bit of advice for your notes, color code them. Because in these notes, you're going to have definitions, you're going to have examples, you're going to have titles. If you take different color highlighters and for, let's say, all the titles, you make them green, all the examples, make them red. Why is that? Because as we go through the semester, you're going to have a whole bunch of pages. Instead of flipping through and trying to go through it, it'll just jump straight to those things and you see exactly what you're looking for. So color code your notes. First step, I got to label X1, X2, Y1, Y2. What is X1? What's X2? Y1 and Y2. Yeah, so this, if you do this, you won't, it decreases the chance of error when you plug them into the equation. Get used to writing down your formulas. Whenever you deal with formulas, write them down. It'll help you memorize them. So that way, if you're given a question, you can just go ahead and just refer back to memory instead of trying to look them up. Now plug and play. Y2 is 9. Y1 is 3. X2 is 5. 9 minus 3 is 5 minus 1. If you can simplify, simplify. They both have a 2 in common. 2 goes into 6 3 times. So this tells me to go from this one to this point, I go up 3 over 2. Let's look at the slope of this one. So this is X1, Y1, X2, Y2. What's Y2? Y1, X2, and X1. 5 minus 2 is 3. 1 minus 5 is -4. Remember, 5 is bigger than 1. It's negative, so the answer is negative. So now our slope is negative. What does that tell you the graph looks like? Right. It looks something like that. That's a negative slope. Let's plot these points. 1, 2, 3, 4, 5. 1, 2. 1, 2, 3, 4, 5. So it looks like this. The slope is negative. So negative slopes, remember, we always read left to right. Negative slopes go down. Positive slopes go up to the right. So we can tell what it's going to look like when we graph it. Or if you're doing homework assignments and it says, okay, which graph matches this equation? If it's a negative slope, always look for the ones that are going down to the right. And then you can go from there. But if it's going to the top, if it's going up, that's not a negative slope. Find me the slope of these two lines. I'll switch these around. So that's the first important part. The reason I'm always asking y'all to label these things is because when we talk about the distance or the midpoint, we're going to use the same numbers. So once you label them, it's just plug and play. All I have to do is introduce the formulas to you. So what's y2? 4 minus y1, x2, x1. So we get 4 minus 4 is 0. 5 minus 3 is 2. That equals what? 0. So the slope here is 0. We'll look what that means in a minute. How about the second one? What's y2? 5 minus y1, x2 minus x1. So what does that equal? Undefined. It can't be 2 because remember, what is division? It says, how many times does 2 go into 0? No, you can't, 0. How many times can 0 go into 2? An infinite number of times. If I promise to give you nothing, how many ways can I do that? Infinite ways. And I'll keep on giving you nothing. So here we have the two extremes. Notice this one is 0. If the y values are the same, your slope is 0. If the x values are the same, it's undefined. I know. What does that have to do with price of tea in China? So the first one was 3, 4. That's our first point. That's point 1. The second point was 5, 4. That's point 2. This graph is a horizontal line. If you have the same y values, or if your slope is 0, then you have it's a horizontal line. So a horizontal graph means your slope is 0. You have to be able to go either direction. If I just give you a graph of a horizontal line, then you have to tell me that the slope is 0. Or conversely, if I give you a slope of 0, you know it's a horizontal line. Or if I give you 2 points, if the y values are the same, then I know my graph is a horizontal line. All these things they're combined together. You have to be able to do all 3 of those. So we have this one, 1, 2, 3, 4, 3. That's point 1, and 4, 5. That's point 2. It's a vertical line. So if you have the same x values in your points, that means the slope is undefined and it's a vertical line. If the same y values, it's a horizontal, the slope is 0. Or if I give you a vertical line, you know it's undefined, you know the x values have to be the same. So all this stuff, they're interchanged. You have to be able to tell me what's happening. So like I said, so if it's a vertical line, you know x value is the same, and so on and so forth. Now, how do you memorize all this stuff? Slope face. This sounds Mickey Mouse-ish, but trust me, it'll help you. He's a droopy kind of guy. And here's his nose. And there's his mouth. Doesn't look too happy, does he? So reading left, right, what kind of slope is this? It's a positive slope. Left to right, this one is a negative slope. If it goes up and down, it's what? What's the slope? Undefined. If it's horizontal, the slope is 0. I've had so many students said that they were in a test and this helped them out. If it's a vertical line, it's undefined. If it's a horizontal, its slope is 0. This picture and this information is what's going to be the most difficult part of this section. I'm just going to say, you have a vertical line. Example. You have a vertical line going through 3, 5. Find another point. If it's a vertical line, what do we know about it? It has the same x values. So the next point has to have the same x value. It's got to have a difference. So I can have, and there's my answer. As long as the x values are the same, it's a vertical line. What I'm saying is, if you understand what the question is saying, finding the answer is easy. The slope is 3/4, and the line goes through 2, 7. Find another point on that graph. Got it? If we drew the picture, we have a dot at 2, 7. The slope says do what? From this point, go up 3, so it's 10, and over 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. So it's 610. This is the y values. This is the x values, right? So if I took my x value and added 4 to it, I get 6. If I took my y value and added 3 to it, I get 10, which is my next point. Make sense? So if you know how to read the slope, the top value is the y value, the bottom number is the x. If it's positive, you add. If it's negative, you subtract from the x, y values. Or you can draw a picture, doesn't matter. That's just slope. We haven't even gotten to the distance, midpoints, and equations, but it all builds from this. Okay, everybody. Today's Wednesday, right? Oh, have a great weekend. I'll see you on Monday then. Wow, time flies.